Hello everyone, welcome to Math Weeks. So today we are going to start with sequence and series. So let's begin. So in the first subtopic we have arithmetic progression. So or most of you know it as AP in the short form. So let's start with our AP. In this lecture we are going to cover AP and GP, and in the next lecture we are going to cover the telescopic series. First of all, what is AP? AP is arithmetic progression, or the definition says that a progression in which the difference between the terms are constant, right? So what do we mean by that? Let's take an example and understand this definition. Say 2, 4, 6, 8 between two consecutive terms. Sorry, a bit wrong definition. This will be a progression in which the difference between two consecutive terms is constant. Now in this example that we took, now let us see the difference between any two consecutive terms. For example, say 4 and 6, so the difference is 2, and if we take another set of consecutive terms, that is 6 and 8, we also find that the difference is 2, and the last pair if we take here also the difference is 2. So we see that the difference between the two consecutive terms is always 2. So we can say that this is an example of an AP, right? Now another example can be 13, 14, 15, 16. So in this example as well, if we take any two consecutive numbers, say 14 and 15, the difference is 1. Another set of consecutive terms would be 15 and 16. If you take here also, we get the difference is 1, and from here also it is 1. So this is also an AP, right? Now if I take an example like this, that can you tell me if this is an AP? Tell me if this is an AP. No, right? Why? Now let's take any pair of consecutive terms like this one, like 4 and 7. From here we get the difference is 3, right? And from here we get the difference as 1. So the difference between the consecutive terms is not constant, so we cannot say this is an AP. So we'll say that this is not an AP, right? So I hope that the basic definition of an AP is clear to all of you. You have all studied this in your class 10th and 9th, right? So I hope that this is clear. I'm repeating it once again, that AP is a progression in which the difference between any two consecutive terms is constant. Okay, and we have seen some example. Now let us move on to the if we can say rules or AP. Okay, first of all let us see the now if I generalize like the examples that I took, if I want to generalize it, we can write, can I write it, let the first term of an AP be, say A is the first term. Now I have to write an AP, so for the first term is A. Now in the examples that we saw, this difference between the consecutive integers is known as common difference, and this difference is constant, right? So this difference is known as common difference, right? So if in order to make an AP we need a common difference, right? So in order to generalize the terms of an AP, let's take the common difference as D. common difference d. I have d be any real number. Now, so if the first term is a, then you tell me what will be the next term. The next term will be a plus d, right? See in the example. So for let's take this example. So it was 13 and our common difference was 1. So if 13 is the first term and our common difference is 1, what would be the next term? We have to add the common difference to the first term, so we will get the second term, right? So if we add 1 to 13, we will get 14. Now if you add again 1 to this number, we will get the third term, like this, right? So here also we have to do the same. If a is the first term and d is the common difference, then the second term will be a plus d. Now what will be the third term? So in the case of 13, 14 and 15, when we added the common difference to the first term, we got the second term. Now what we have to do is we have to add the common difference to the second term in order to get the third term, right? So we, in our case, the second term is a plus d. So what will be the third term if our common difference is d? It would be nothing but a plus d, which is the second term, plus the common difference. This will be the third term, or if you add the d's, you will get 2d, right? Now what will be the fourth term? In order to get the fourth term, we have to add the common difference to the third term. Like this we will move forward, and the fourth term will be a plus 3d, because we have to add the common difference to the third term in order to get the fourth term. So if you carry on this process, do you see something interesting right here? So if I state this as t1 now, and the second term if I call it t2, the third term be t3, like this and that. So see, can I write t1 as a plus 1 minus 1 into d, because this will ultimately be 0 and this whole term will be 0, so it will be left with a. Okay, so the first term, it will remain a. Now if we talk about the second term t2, now our t2 is a plus d. Now can I write this as a plus 2 minus 1 into d? So this will be 1 and this will remain a plus d. So the second one we can also write it as this. Similarly, third one we can write it as a plus 3 minus 1 into d, like this. Now can you tell me, if you have seen a pattern, can you tell me what will be the nth term? The nth term will be nothing but a plus n minus 1 into d, right? Because we have seen a pattern. In the first term we have to subtract 1 and multiply it with d, so that we will get the first term. Similarly, if we are talking about the second term, subtract 1 from 2 and multiply it with d and add to the first term. Like this we have seen a pattern, and we have now come across the general term of an AP, that is the nth term of an AP, that is Tn is equals to a plus n minus 1 into d. This is the general term of an AP. So I hope that this general term concept is clear to all of you. We have done nothing but we have just seen a pattern in the numbers and we have generalized it, right? That's what mathematicians do. Now if this generalization concept is clear to you, let's move on to another concept. Now let me give you an question based on this generalization step. So if an AP, let there be an AP with first term say 12 and common difference, this is common difference as 2. Now it is asked to find say 12th term. Do it. Done. So it's a very easy question. So we know that Tn is equals to a plus n minus 1 into d. Now we are asked to find the 12th term, so it will be t 12th, right? We have to replace n with 12, and it will be 12 minus 1 into d, right? You know the value of d, that is 2. You know the value of a, right? A will, what is a? 12, so this will be nothing but 12 12 plus 22, that is what, 34. So the answer is 34. I hope that all of you were able to solve this question, right? Now you can practice such more questions. This is very easy. Now let us move on to a more important concept, that is the summation of AP. This is, now we are going to talk about the summation of AP. Now if I tell you how we got this formula, this formula was discovered by Frederick Carl Gauss, the prince of mathematics, when he was studying in class 4th or 5, something like this. He discovered this. So now let's study how he got the result. Let Sn be the sum of AP. Sn is an it's a, say, a notation kind of thing. Sn is the sum of an AP, represents sum. So say this is a. Now tell me the second term. This will be a plus what, d. What will be the third term? This will be a plus 2d. And similarly, since Sn we have to go till n term, so can you tell me what will be the n term? Nothing but a plus n minus 1 multiplied by d. I consider the first term is a and the common difference is d, right? Represents this the sum of n terms of AP, of this AP. Okay, so I consider a is the first term and d is the common difference. Now can I write this as this, and as well if I just do some rearranging, can I write this as can I write it like this? Obviously, right? Now this is the same as this one, and this one is same. I just rearranged it. So if you add both, what we are going to get is 2Sn. But interestingly, in the RHS, if you add this term with this term, if you add this term, what we are going to get? 2a plus n minus 1 into d. Again, if you add this and this term, what you are going to get? You are also going to get again the same result. Again you are going to get 2a plus n minus 1 into d. You can check it, and if you do this, the same thing to all the terms, you will get the same result only, that is 2a plus n minus 1 into d. Now you tell me how many terms are there. Obviously there are n terms, right? So how many 2a plus n minus 1 into d we are getting? How many such terms we are getting? N terms, correct? You can check this by your own. Just add up this and this one, this and this one, continue the process, you will get the same result, that is 2a plus n minus 1 into d. And since there are n terms, we are going to get n numbers of such terms. Hence we finally get the result as Sn is equals to 2a plus n minus 1 into d multiplied by n divided by 2. This is transferred to RHS. So this is the formula of summation of AP, where A first term and D is the common difference. I hope that this is clear to all of you. I did nothing, I just assumed that Sn be the sum of n terms of an AP, and I wrote the AP with n terms. I taught you how to write the general form of an AP. So I did this, I added this again, but I did some rearranging, and the result every time I'm getting is 2a plus n minus 1 into d. And since there were 8 n terms, we are going to get n times this whole expression, and we have derived the formula. The derivation is not necessary for a PRMO, the formula is, so remember this result. I hope that this is clear. Now interestingly, the formula that we just got is Sn n by 2 2a plus n minus 1 into d. Again, I'm just doing nothing, just expanding this. Can I write this as a plus n minus 1 into d? Can I write this? Now if I can write like this, now tell me which term is this. Do you see something like common here? I have taught you something like this. Yes sir, yes, we see that this is nothing but the last term, the nth term, right? Nth term, I see, I told you that nth term is nothing but a plus n minus 1 into d, where a is the first term and d is the common difference. Similarly, a is the first term and d is the common difference I considered here. So in most of the books, the last term, nth term, is denoted by L. So this is also nothing but a plus L. L here represents the last term. Okay, so I hope that this form is also clear. If you know the last term, you can directly derive the sum of the terms of the AP, and if you don't know the last term, then use this form where it is only needed the first term and the common difference. And if you try to solve with this, you also need the last term, right? I hope that the summation is clear to all of you, and the general form is also clear to you, and what is an AP is also clear to all you. Now let us talk about this is also from AP, arithmetic mean. Arithmetic mean, what is arithmetic mean? Arithmetic mean, I'm not going into the definition because it is not also very important. So what you need to understand is, if A, B and C are in AP, they are in AP and they are in AP, so I say that 2b is equals to a plus c, or b is equals to a plus c by 2, and here b is the arithmetic mean of a and c, of this arithmetic progression. Now how to prove that? Very simple. See, a, now how can we write b? If I a is the first term and I take common difference as d, so we can write b as a plus d, obviously, right? And c as a plus 2d. So if you add a and c, so we get 2a plus d, and a plus d is what? B, so we get 2b is equals to a plus c, correct? Now b is the arithmetic mean for this AP. Now what if we have n arithmetic mean? Obviously, right, we can have n arithmetic means. Now see how to find this. Say a is the first term of an AP, and B is the last term of an AP, and in between them there are n arithmetic means. Okay, there are n arithmetic means. Now if I name this as T1, now can you tell me what will be, how can I write T, like how can I write B, what will be the notation? This will be Tn plus 2, correct, right? Obviously, because this is 1 and in between there are n terms, so the last arithmetic mean will be Tn plus 2, and the B we can write it as Tn plus 2. Think about it, take your time. See, this is T1, we have n terms in between, and we have to find what we can write B as. So T1 and in between n terms, and then after we have B, so this will be Tn plus 2, right? Now if this is Tn plus 2, so we see that if I talk about the first arithmetic mean, say A1, this will be second term T2, right? Obviously, right? This will be second term T2. Now T2 can be written as A plus D because this is the second term. Another thing is that if this is the last term Tn plus 2, how can I write this as, I can write this as A plus n plus 2 minus 1 into D, right? Because we know that whatever we have in this place, we have to subtract 1 from it and multiply it with D and add to A, right? This was the form Tn is equals to A plus n minus 1 into D. Now we have n is equals to n plus 2. This n and this n is not same, so don't cut them, so just replace this n with this one, so you will get this. So we see that B is equals to A plus n plus 1 into D. Remember this. And now from here what we can write, can we write B minus A upon n plus 1 is equals to D? Can I write this? Obviously, right? We have done nothing, we have just written D in terms of A, B and N. Okay, now let's come again to this point. So we have here D, so can we replace the value of D from with this value that is B minus A upon n plus 1? So if you do that, what we will get? We will get as A1 can be written as, or T2 can be written as A plus, that is B minus A upon n minus 1, correct? Now tell me the second arithmetic mean, that is T3. The third term will be A plus third, since 3 minus 1 multiplied by D, so this will be 2 multiplied by B minus A upon n minus 1, right? Like this. And if you continue this, and if you ask me that, sir, now tell me what will be the nth, like what will the nth arithmetic mean of this whole AP, then this will be, if you see a pattern right here, like since you asked the first arithmetic mean, so we can consider it with multiplying with 1. Then if you, we have asked the second arithmetic mean, so multiplied with 2. So if you ask me the nth arithmetic mean, that then we will just simply A plus multiplied with n, B minus A upon n plus 1. This is your nth arithmetic mean formula. I hope that you understood how we derived all this. I am explaining once again. So we considered A be the first term of an arithmetic mean and B be the last term of an arithmetic mean, and in between them there are n arithmetic means. So if there are n arithmetic means, then how can now what will the b? Like if I say a is t1, how what will be the b? What can I write b as? So we can write b as t n plus 2, since a is the first term and in between we have n terms. Now what how can we write that b? So b can be written as a plus n plus 2 minus 1 into d, and we have to add it to a. From here we got the value of d, and what will the a1 will be the second term of the ap, which we can write as a plus d. We have substituted the value of d from here, and then we have written the second arithmetic mean, or the third term of the ap. Like this we have seen a pattern that the number of the, like if you ask me the first arithmetic mean, we have to multiply the common difference with 1. If you ask me the second arithmetic mean, we have to multiply the common difference with 2. In this order, if you ask me the nth arithmetic mean, we have to simply multiply the common difference with n, right? I hope that this is clear. So with all this discussion, our AP is finished. And now I hope that this whole discussion was clear to all of you. Now we will move ahead with geometric progression, something that is new for all of you if you are in class 11th. Now, what is arithmetic progression? Geometric progression, right? Or GP. Now for GP is a progression in which the ratio of two consecutive terms is constant. Okay, one small thing I forgot to tell you, that is, if I tell you that, for example, if I tell you that 2 comma 2 comma 2 comma 2, is this a arithmetic progression? Yes, it is an arithmetic progression with common difference 0. Okay, so if you add 0 0 0, you will get the same. Okay, this is a very common thing, but I thought of telling you. Okay, let's get back to the GP. So geometric progression is a progression in which the ratio between two consecutive terms is always constant. For example, in this example, in this sequence, let's take the ratio of any two numbers, say this two consecutive terms ratio, which is 2, right? 8 by 4 is 2. And similarly, if you look at this pair here, from here also the common ratio is 2, and here also this 8 and 16 also common ratio is 2. So we can say that this is an GP, right? Geometric progression. Another example, if I take now, tell me, is this in GP? Yes, because if you look at any of the two consecutive terms and find their ratio, this will be 5. Similarly, in this case also it will be 5, and this case also this will be 5. Okay, I hope that the definition is clear to you. What is GP? So now again we will follow the sequence of arithmetic progression. Now we are going to find the general term. So let's take the first term as a, and the common ratio r. I hope that now you understand what is common ratio. In arithmetic progression, we have to add the common difference, and in this case we have to multiply a constant like a number. So in the example 525, 125 and 625, see, if we multiply it with 5, we are getting all the numbers, right? Now see, a very beautiful thing. 5, can I say it as t1, right? Obviously, right? Now what will be the t2, which is 5 multiplied by 5. Now what will be the t3? Nothing but 5 multiplied by 5 multiplied by 5. Do you see, in the first term we have multiplied 5, we have got the second term. In the second term we have multiplied 5, we have got the third term. So we are just multiplying the common ratio. Okay, now we have seen this with an example. Now if I want to generalize it, like I have taken the first term a and the common ratio as r, so I can say that I can construct a GP like this a. Now tell me the second term, if the common ratio is r, everybody ar, what would be the second term? Ar multiplied by r multiplied by r. This can be written as ar square. Now similarly the third term will be, fourth term will be ar cube. Now if I say this t1, t2, t3 and t4, so t1 is a multiplied by r to the power 0, right? Because this will ultimately be 1 and this will remain a. And t2 can we write this a r. Now can I write this as ar2 minus 1? Can I write this? Obviously, right, because 2 minus 1 is 1 and r remains the same. Similarly, if you see at the third term, the t3, that is ar square, right? This will be ar square. This will be the second term is this one, and this is the third term. So the third term is ar square. So can we write it ar3 minus 1? It remains the same, right? It's just a way of writing. So if you look at this, now can you tell me what will the nth term? This will be nothing but ar n minus 1. I hope you got it. Okay, I hope you got it. We have done nothing but we have just seen a pattern and we have generalized it, right? I hope that this is clear. Now let's move on to the summation of GP. Summation of GP is also similar kind of a, say, Sn. Again the first term is a, the common ratio is r, so the terms will be a plus ar plus ar square and up to, if I take n terms, it will be ar n minus 1. Now if I multiply Sn with r, now tell me, I'm just writing it with a space. If this will be ar plus ar square plus ar cube up to arn, right? We have just multiplied r to this whole progression. Now after doing this, if I subtract this 2, so Sn minus rsn is equals to, now see, this term gets cancelled, this term gets cancelled, and similarly all this gets cancelled, and what will be left is a minus ar power n. Correct? This is what we will be left with. Now if you simplify it, Sn will be n minus r n upon 1 minus r. Correct? Now this is your answer. Now this thing is well. Now see, a very important thing. I hope that this one is clear. Now if I take r greater than 1, okay, if I take r greater than 1, then what will happen? Then this, after multiplying the whole progression by r, this sum will be greater than this sum. Like rsn will obviously be greater than sn, correct? Because r is greater than 1. In that case we have to subtract sn from rsn. Do you understand it? In this case we have to subtract sn from rsn, but in this case we considered r less than 1. So if r is less than 1 and we multiply sn with r, obviously rsn is less than sn, and hence we have to subtract rsn from sn. Okay, don't get confused in my way of saying. Just think logically. Now I'm giving an example. Say 2. Okay, if we take r greater than 1, say 2, r equals to 2, this will be 4, 8 and 6. I'm taking only 4 terms. Now on the second line, if on the again, so if we multiply, so if we sn in this case will be 2 plus 4 plus 8 plus 16. Now if you multiply sn with r, see r is greater than 1, so obviously rsn is greater than sn. So you tell me what will be now the form. Will I subtract rsn from sn, or I will subtract sn from rsn? Obviously, since r is greater than 1, we have to do this one. Now again, if we take another example of r being smaller than 1, then see the case. Say I take r as half. Okay, r is equals to half. So what will the sequence say? Say I take 4, then 2 and then 1. I'm taking only 3 terms. This will be sn. Now if I multiply it with r again, rsn will be 2, 1 and half. Now you tell me which one is bigger, rsn is bigger or sn is bigger? Obviously sn is greater than rsn. So in this case we have to subtract rsn from sn. I hope that now it is clear. So the two formulas that we get from the summation is that if r is greater than 1, we get arn minus r ar upon r minus 1. This is the, so this will be the formula of sn. And now if r is less than 1, then you know the form ar minus arn upon 1 minus r. Okay, now if r is now sum of infinite gp. Now see this form. If I take okay, so I did a very small. So this will be ar. Here also this will be ar. Sorry for the mistake. Now if I take a common, so this will be 1 minus r n upon 1 minus r. Now I said that n is infinity. If n is infinity, now you say me, and r is less than 1. Okay, r is less than 1 and greater than 0. Okay, I again forgot to tell you one condition, that r is greater than 0. Sorry, in this case there will be no, but r is less than 1 but greater than 0. It has to be greater than 0. Okay, this condition, remember. So if n is infinity, then see, this term is like 0. It tends to 0. So since r is between, say, half, if I square it, 1 by 4, if I then again square it, 1 by 16, so see, it is decreasing and decreasing and decreasing, and now we are considering that the power is infinity, so it will be decreased so much, then we can consider it as 0. So if this is 0, this remains as a upon 1 minus r is equals to s infinity. Okay, remember this condition, that if r is less than 1, it has to be greater than 0. Okay, so I hope that this all forms of summation is clear to all of you. Now let us move on to the geometric mean. Geometric mean. Again, for an example, if a, b, c are in GP, so we can write, and common difference is, say, r. So b can be written as ar and c can be written as ar square. So again, b is the so the geometric mean would be root of AC, that is b. What is root of AC? Now you can see it yourself, a multiplied by ar square under root, so this will be ar, which is b. Now what if n number of geometric means are there? Very simple to make, very simple to understand. See, again, take a and b, and there are n GMs or geometric means in between them. So b, now again, if I take it as t1, this will be tn plus 2, and if I want to write tn plus 2, I taught you the general form of a GP. This will be nothing but ar n plus 2 minus 1, which will be ar n plus 1 is equals to b. So r n plus 1 would be b upon a, or r would be b upon a, right? This is simple. Like if I say 2 square is equals to 4, so 2 would be 4 half, right? I hope that you know all of this. So if we have got the value of r from this whole thing, now you tell me the first, what will the first geometric mean? That is g1, which is nothing but t2. T2 is ar, or a multiplied by b upon a n plus 1. Correct. Now if I say find g2, that is t3, this will be ar square, this will be nothing but a b upon a 2 upon n plus 1. And if this is in power, okay, my writing is horrible, but please manage with it. So t3, that is g2 or geometric mean 2, this will be a r square. So I was telling you that this would be, now do you see a pattern? The second geometric mean is a b upon a raised to the power 2 upon n plus 1, and the first was 1, so I mean like a multiplied by b upon a raised to the power 1 upon n plus 1. So if you continue this pattern, so you will find that nth geometric mean is nothing but a multiplied by b upon a upon n, like raised to the power n upon n plus 1. So this will be the form of nth geometric mean, right? We have just I am telling you again and again, we are just generalizing a pattern that we see. I hope that this is clear. Now we like this is a commonsensical thing. Let me just tell you, if asked that three terms of AP is there, so how to write three terms on AP such that it is useful for us? We write it as a minus d, a plus d. Now first of all, why we write this I am going to tell you. How we write this I am going to tell you now. Now check this. If we can write like this, a minus d plus a d, obviously, right, d is the common difference between them. Now what is the use of this? If the use of this is that the common difference gets cancelled, and the only term that we are left with is a if we add them, right? So this is the use of it, and we are going to use it in a lot of questions. Now similarly, if asked find 5 terms of AP, I'm talking about AP right now, so this will be what? Nothing but a plus d, a plus 2d, and it will be a minus d, a minus 2d. This will be the form if d is the common difference and a is a term of the AP. See, so if we add them, all the d's get cancelled and all we are left with is a. So in this, like in the question, it will be given like 5 terms of an AP whose sum is such a number. So the use of this is we can directly get the value of a, one term of that AP, right? Now it is very easy to find this type of terms or form when asked with odd numbers like 3, 5, 7. It is very easy, but once they say the sum of 4 terms, it is not difficult, I would say, but you have to use some of your brain cells to get that. So I'm showing you one example, like 4 terms. If said 4 terms, and you can just use some of your brains and then get 6 terms like that. So this can be write like this, and okay, so 1 2 3 4. Okay, right, 4 terms. If you add them, the d's get cancelled and all we are left with a. So like this, you have to use some of your brain and just get the form for even terms of an AP. But if asked the odd terms, it is very easy. Just subtract and add the common difference. And also one thing that you see here, the common difference was d, and here the common difference is 2d. So for all odd terms, the common difference you can use to find this form is d. Like if asked 9, so the middle term would be a, and then just in the right hand side continue with adding d, and in the left hand side continue with subtracting d, if odd, in case of odd. And in case of even, you have to use some brain, right? Similarly for GP as well, if asked to find 3 terms of GP, any GP, say the middle term is a, then the next term will be AR, and the previous term will be a upon divided by r, right? If the r is the common difference, so what is the use? Multiply it, r will be cancelled and you will be left with a. Similarly, 5 terms, the answer will be a, then the second term will be AR, third term AR square, and the previous term will be a upon r plus a upon r square. I hope that you understand why we are dividing r. I hope that you understand, because see, this is in GP. So if I consider this term 8, and if it is given to me that the common difference is 2, and asks, and like a question I'm telling you, if you did not understand why I'm dividing 2, see, question given that the third term of a GP is 8 and common ratio is 2. Find first term and second term. Now see, third term is given to you, so we can write the AR square is equals to 8, and that r is given to you 2, so if you divide 8 by 4 you're going to get 2. That is the first term. Now see, 2, we are dividing it by, to get the first one, to get the first term we are dividing it by square. Okay, and if we want to get the second term, we can write the AR multiplied by R is equals to 8. We have to divide it by R. Use this logic in and generalize it. You will get why I am dividing it by R. And this is very simple, extremely simple. Okay, use the logic that I used here, and you will find the answer to your doubts. And for the even, again, you have to use some of your brain to get there. Okay, so till here our concepts are done of AP and GP.